of the experience, immersing us in interactive journeys like no other medium can. Achieving this in an open world as vast and systemic as Assassin's Creed Shadows is requires a custom engine built for scale and complexity. An engine just like ANVIL.
Japan was an highly expected setting for us, so we treated it very seriously, wanted to do the best game visually as possible, and we wanted to push the limits.
We wanted to put everything on another scale, another step in the quality and the immersion for the gamers.
So, how did we build it? How could we create a world that feels this real? And what did it take to carry out the game's creative vision? Organizes every moving part of the experience in an open world for scale and complexity. An engine
everything on
feels this real. And what did it take to carry out the game's creative vision in an immersive open world of massive scale?
What about making the world as dynamic as possible? What about having dynamic seasons that will change throughout the whole world? All of this would not have been possible without the support of the ANVIL people.
We feel like the only way to realize this artistic vision was to use the ANVIL engine and to evolve it to its next generation iteration.
An evolution that impacts everything. Like a single drop of water, or thousands of them. All simulated living objects, every drop contributing to a dynamic weather system powering our open world experience. Atmos. From the start, the team's ambitions were to create real-time seamless weather simulations, something truly unique that would reinforce the sense of place and continuity central to Assassin's Creed.
One of the key pillars for Assassin's Creed Shadows was dynamism. So this is where Atmos played a big role because we wanted a world that was immersive as possible.
Atmos is our physically based weather system. It leverages a wind simulation and propagates various atmospheric quantities such as temperature, vapor, humidity to determine if, for example, it's raining somewhere or there is a wind somewhere.
ANVIL is built on the same physical principles that govern the real world. Let's go back to our water. It will evaporate under the hot summer sun, form clouds as vapor rises, and eventually turn into rain, all seamlessly in real time.
So in terms of gameplay, we affect the crowd, we affect people, we affect the animals, we affect the living world. That change what you can do and change your experience.
You could walk in Iga provinces and see different weather states coming in and out, and that will greatly immerse the player in all seamlessly. It's not on loading, so it's happening in real time. This is huge. This has never been seen before within the brand.
The true power of Atmos resides in its ability to synchronize every weather-related element to create a sense of coherence between them. Like wind blows rain on character models, moves their clothes, and tussles their hair. In Assassin's Creed Shadows, coherence is key to immersion.
Atmos is more like a maestro with all the ingredients. The rains, the lightings, the sounds. It will use the wind simulation for the cloud generation, but the simulation of the wind is a system itself that is just used by Atmos.
What really shines in Assassin's Creed Shadows is how everything uses this wind information to behave in a cohesive way, so everything works together.
If we talk technically, we have like kind of fluid simulation we are using to drive multiple systems. And we compute multiple fluids that are connected together to affect winds on all our systems.
The team also developed what they call spray particle systems. So basically, it's a dynamic wind with collision that will carry particle over. So if you add up weather state, Atmos, and spray particles, it's a perfect recipe to create like a very immersive and dynamic world.
Atmos's unparalleled dynamism then sets the table for an equally unmatched memorable experience. One minute, you are deep in the forest, hunting your prey as sun shines through the canopy. The other, a thunderstorm is formed above you, changing the mood completely and seamlessly.
Whenever the player will be walking around a place or another, the cloudscape and the effect will not be exactly the same. so it will always be a surprise.
We saw, in the mini-game reviews and player feedback that some of them, they were avoiding fast traveling because they enjoy the systemic changes that happen throughout their travel within the world. So that shows how powerful the system that we've put in place.
Sometimes I would just stand in a world in Kyoto with a storm, and I would just look at the cloth of Naoe, or the hair, or the rain being moved by the wind, all in a cohesive ways, and I was just speechless.
ANVIL allows Assassin's Creed Shadows' feudal Japan to be an awe-inspiring place to get lost in. A living world breathing through a dynamic weather simulation that has a real impact on the world it inhabits, the players that experiences it, and the people that created it.
Of course, I'm proud of this because making video game it's an odyssey in a way. There's a lot of people involved, and when you're able to see the final result, how the system working together, you could tell, and we did achieve something special, and we could not have done it without the ANVIL people.
And it's only just the beginning. ANVIL will keep pushing the boundaries of immersion and open world design to the benefit of you, the players. Video games invite us into extraordinary worlds, some of massive dimensions. Creating such vast playgrounds without breaking the player's immersion is a real challenge, even more so when optimizing the experience across different platforms. A challenge that the ANVIL engine was built to overcome.
The DNA of the ANVIL engine is to build systemic open-world games.
Scalability was one of the first goals. The idea was to provide a good quality no matter your choice, and also to provide good resolution and good performances.
So how'd we do it? How could we balance our game's need of realism and immersion with the limits of gaming hardware and production constraints?
When we talk about scalability in ANVIL, there are two dimensions to this. There is a scalability in the sense that we want to render a very large world, but at the same time, the scalability is also in the range of platforms we support.
At the core of this vision lies a fundamental capability of the engine, rooted in its architecture, large-scale rendering and scalability, or its ability to make massive worlds run seamlessly. Assassin's Creed Shadows is one of the biggest open worlds in the series. Multiple processes and solutions needed to be planned from the get-go to make sure it stayed strong and cohesive as the teams filled it with dynamic systems and content.
In this kind of game, the scale is the main challenge. And we have to handle very tight budgets for memory in general because we want to fit as much details as possible. So streaming was definitely a challenge, and making sure all the dynamic systems behave in a cohesive way together so they deliver the best result.
If you start to see popping, it broke the experience. So that's something that is pretty complex to achieve. And within ANVIL, we have a lot of automatic systems that adapt to the situation that will do the work for you. So the artists only focus on quality.
If we go back in time, we can see that the Assassin's Creed games got bigger and bigger. So at the start, they were more like what you could define as open city games. But later on, the games got much bigger with Assassin's Creed Origins, what we would really truly call an open world.
We have a lot of subsystems to maximize the long-range rendering. This creates LOD continuity between one asset that will become one tree at 2, 4, 6 kilometers away.
But there is also a second layer of scalability to Assassin's Creed Shadows. Creating a groundbreaking immersive open world was not the sole objective. It also had to be adaptable to comply with as many gaming platforms as possible.
One of the magic of the system is also to work with context. If you're in a game, or if you're in cinematic, or if you are in the hideout, we can change the entire rendering properties and adapt to the current situation to keep good performances and good quality.
If the engine wasn't scalable, for example, it would have meant much more scoped areas, maybe in more closed environments or smaller maps connected to another by loading time.
The objective was to keep super good quality from close range to super long range.
The ANVIL engine allows Assassin's Creed Shadows to immerse the players in its dynamic rendition of feudal Japan in seamless fashion. Thanks to scalability and large-scale rendering technology, the teams have developed the means to achieve their creative vision and to keep delivering quality experiences on a large spectrum of gaming hardware. They are setting a new standard for video game open worlds.
The future of ANVIL, I see it in multiple ways. I see continue pushing the dynamism, having a better living world, giving tools and technique to creative teams to achieve their goal. Shadows was the first step toward the future.
Video games invite us into extraordinary worlds, some of massive dimensions. Creating such vast playgrounds without breaking the player's immersion is a real challenge, even more so when optimizing the experience across different platforms. A challenge that the ANVIL engine was built to overcome.
The DNA of the ANVIL engine is to build systemic open-world games.
Scalability was one of the first goals. The idea was to provide a good quality no matter your choice, and also to provide good resolution and good performances.
So how'd we do it? How could we balance our game's need of realism We previously explored how ANVIL's many systems work in concert to shape a best-in-class dynamic open world. From simulation to rendering, each tool plays a part in sustaining immersion at scale. To fully realize Assassin's Creed Shadows' vision, we now dive into another essential facet of ANVIL's capabilities. One that affects the level of detail, or LOD, shown on 3D objects.
It's all about quality from close range to seamless transition in long range.
Before, you could be distracted by LOD pop, and now that's not the case anymore.
So how did we do it? How did we build a historically grounded open world that preserves a sense of journey without cutting back on the level of visual details and immersion?
Our vision is to deliver less and less friction to the artist on the floor. And for this, it's what I would call no grunt work. It's like you don't have to build LODs by yourself. They are automatically built. The gains are so big in terms of details and what you can represent in the world that it's the future. It's already the present, actually.
A vision that we will illustrate with this house. One of the many objects within which lies the secret to the evergreen visual details of the game world they inhabit. Micropolygon geometry. The 3D objects you see and interact with in a game world are created from polygons, connected with each other to form a mesh over which textures and materials are applied. So, as a rule of thumb, more triangles means more visual detail.
In the past, for example, when you were doing rock, it was like 20K triangle, 40K triangle. Today we can do 400K, 2 millions, 4 millions triangle. The main purpose of micro-polygon hierarchy, micro-poly, it's to remove the limit of triangle.
That's fine when dealing with a closed map featuring only a handful of houses, but what about dealing with a massive dynamic open world?
Macropoly features works with a concept of automatic occlusion that allows both dense area and more vast landscape to render efficiently. It simplifies the work of artists. They basically don't have to bother anymore about LOD generation.
Thanks to micropolygon geometry, the concept of level of detail essentially becomes a thing of the past. Triangles from which 3D objects are created are constantly adapting to what is visible to you. Depending on distance from said object, the house in our example, ANVIL streams only what's necessary, managing resources efficiently and staging the most immersive open world possible around the player character.
Using micropolygon, there is no more LOD. We have still LOD switch in very far distance, like near-fx and far-fx. We are able to cross-dissolve between them to hide any popping. And it's also here to give the ability for an artist to not have to think about the number of material you have to put on the mesh or the number of triangle you will use. Something we were doing by texture before, today we are doing with real geometry. It removes limitation from the content creators.
A dynamic and expertly crafted open world whose visual fidelity adapts in real time relatively to your position and the movement of your camera. That is the perfect recipe for an utterly immersive video game experience. Perfect for gameplay, yes, but not necessarily adapted to in-game cutscenes where camera work differs drastically.
In general, in a normal gameplay scenario, the camera is transitioning smoothly, but during a camera cut, the transition is too sharp, so we have to load in advance what will be visible in the next second. I think it's a kind of feature eventually that the player doesn't notice. But it's like a lot of things in games or in software development that if you don't notice something bad, it's actually good.
In the end, the team's ambitions for Assassin's Creed Shadows had them revisit their approach to how they should create a breathtaking dynamic game world. It was less about putting as many visually impressive models as possible all at once than it was about working smart by only showing to the player what needed to be shown.
We are very happy with what we delivered because if we consider the time it takes to develop such features, like it's multiple years of development, and we feel like we reached the level of quality, visual quality that we wanted in the game.
Micropolygon geometry is the perfect feature to cement ANVIL as an open-world video game powerhouse, and to give the developers the means to achieve their ambitions. Across this series, we've explored the technologies that bring Assassin's Creed Shadows' feudal Japan to life, from dynamic weather systems to scalability and micropolygon geometry. We now turn to light itself, one of the most challenging yet essential ingredients of a truly immersive game world, a challenge ANVIL was built to meet.
From the beginning, the objective of the game was to put more dynamism to the world.
Traditionally in games, and in Assassin's Creed as well, the lighting was very static. And now with the dynamic ray tracing, we can achieve a similar quality or even better, but with a much more dynamic world. So it opens the scope of possibilities to things we couldn't do before.
But how did we do it? How did we integrate a true-to-life dynamic lighting system to a large-scale game world that is constantly changing?
Just imagine, you have season, you want more dynamic objects, you want dynamic lights. All of this drives the decision to have something much more dynamic. The ray tracing global illumination provides that ability. It's real time.
an ability that stems from millions of rays of light that, just like in real life, bounce, morph, and react to their environment. That is the power of ray-traced global illumination. The way a scene is lit is crucial to its believability. It is the element that holds everything together.
Ray-traced global illumination is about simulating the behavior of light that bounces off geometry in-game.
We are using two systems. One that is probe-based, so dynamic probes in a cascade around the player. We also have per pixel using the probe to refine what we have. And then we are using multiple systems, like denoisers, to increase the quality result.
In the past, we had baked light probes that were pre-computed offline in the world. But the problem with this approach is that global illumination was static, so it couldn't accurately represent all dynamic objects in the world.
For example, if you stand in a house and you open the door, the lighting won't be affected by this. But with dynamic ray tracing, then once you open the door, all the lighting, all the environment adapts to the scene, and then it looks more believable and more grounded.
But it is only after working for a few months on the project with baked global illumination that the decision was made to implement RTGI in the pipeline, a decision that would prove optimal for the teams and unparalleled for player immersion.
When we started working on ray tracing, we started from scratch in the ANVIL engine, but we knew other teams at Ubisoft were working on the same topics, such as the Sandrop team at Massive. And so we collaborated with them as well to exchange knowledge and share. We elevate the technique together.
It's a good thing that we have our own engine, and that's why it's relevant, because you can really tune your engine for your specific need for your game and optimize it. For Assassin's Creed Shadow, we optimize it for size, for dynamic scene. For example, we had also some lighting that were coming through paper door.
And because of this, we had to implement specific techniques like indirect translucency to simulate the behavior of light being scattered through paper to improve the illumination in interiors.
And also, you know, since we had a lot of vegetation in shadows as well, so you could see the translucency of the leaf, the bleeding of the greens or the colors on the ground, so it grounds everything.
Thanks to RTGI, rays of light projected through feudal Japan perfectly simulate the reaction of real light when interacting with certain materials, lighting up a dark, stormy sky, or getting snuffed out for a stealthy approach. However the world morphs around you, lighting is consistently and seamlessly adapting.
Lighting quality definitely improves the player's immersion because every element of the game feels properly integrated in the environment, and that's important that the world feels coherent and natural to the player.
Some people say that it's just about look, and it is about look, but having something that is really pushing the boundary on the visual quality, I think it's really helped the immersion. And in a way, it can help the player to be really inside the story and live it better.
ANVIL's ray-traced global illumination technology brings never-before-seen coherence and adaptability to a world of massive scale.
To me, ray-traced global illumination is the future, and we'll keep improving this technology on future games because it offers many advantages compared to previous technologies.
The barriers set by past lighting technology have been broken. With real-time, physically based lighting, Assassin's Creed's worlds emerge with a renewed sense of place, dynamic, reactive, and grounded in history. With ANVIL enabling its ambitions, the future of the franchise looks particularly bright.